Presentation learning, Ramesh has been a significant contributor to the field of visual intelligence since 2010. His work primarily revolves around solving real-world problems by developing advanced AI-based solutions, focusing on 2D, 3D content creation, data processing, computer vision, AR, VR, XR technologies. As a faculty member and researcher at the Center of Excellence in Visual Intelligence, CEVI, he actively engages in innovative projects and collaborates with global experts to advance AI applications. In his academic career, which began in 2013, Ramesh has played multiple roles, including assistant professor and researcher at KLE Technological University. He has been instrumental in fostering a dynamic learning environment, contributing to the growth of the student ecosystem for engineering data seed and guiding numerous students and researchers in their academic and professional pursuits. His prior experience includes a consultancy role at Samsung R&D Institute, India, and an assistant professorship at SDM College of Engineering and Technology, where he coordinated technical training, research, and development activities. Ramesh's educational background includes a bachelor degree in computer science and engineering from SDM College of Engineering and Technology, Masters of Technology in Digital Electronics from BVV College of Engineering and Technology, and he is currently pursuing a PhD in representation learning at KLE Technology University. His extensive knowledge in programming languages like C and C++, coupled with his proficiency in deep learning and neural networks, has made him a prominent figure in this field. His multilingual abilities in English, Marathi, Kannada, and basic proficiency in Hindi further enhances his ability to collaborate and communicate effectively in the diverse environments. We welcome Dr. Ramesh here on the dais. The dais is yours now. Thank you.
So probably I'm audible to the end? Yeah, great. So welcome you all to this session. Thank you, sir, for your generous introduction. So first I will take a couple of minutes to tell you about why today's session is very important and how can I contribute to this AR VR. See, there is a consortium a government of India has made called BIS Hallmark. I hope everybody's heard of BIS Hallmarks, where generally when we buy gold, right? Similarly, we have hallmarks for all the softwares also. So there is a committee which is governed by this BIS Hallmark for metaverse also. So I hope you have heard about metaverse before. Metaverse is a separate universe that we have created through this AR VR, and Government of India has been behind making rules and regulations for people to use being these metaverse as well. So one of the committee members for Government of India is me and Dr. Uma, who is my supervisor. So there are selected 15 members from India who talk about what this metaverse AR VR should be. And I am bringing that knowledge of whatever discussions we have done in those committees and forums in front of you, so that probably you might foster these into your curriculum, and then probably these academic things would reach students and we grow the ecosystem for AR VR. So certainly many people might know initial slides which are put into. Me and Dr. Sindhu, who is going to conduct session tomorrow, had interaction. So we tried to keep it non-overlapping a lot of things. So we will cover the foundations required for AR VR to understand for the laboratory sessions in the afternoon, and also the fundamentals required to understand Unity, which is a platform which we'll be using to implement all this. So any questions you can stop me and ask then and there. If you want me to change the mode, go faster, slower, you can let me know. Probably I've started at 12:15, so I will take around an hour to finish my session. So I've named my session as Breaking Boundaries of Realities because the reality today has become virtual anyhow. Everybody is moving on to your mobile phones. Whenever I give a speech here, a lot of you are not interested because you get this content very easily online as well. But how do we connect to people has changed today. When you meet people earlier, you met people earlier, that was very different than what you meet today, is because of this technology which is coming in, and mobile phones are available, everybody's status is up, and when I meet my friend, I know about him more than he knows, because I've seen his status more keenly than him, right? So tomorrow would be where our holograms would be, people would listen to us in different modes. I might not have to come to college for hearing lectures. I might meet my class friends or classmates in the classroom, which is really virtual, right? Probably there would be gears where I sit in my room and create an environment. My room would be empty and I have gadgets all over. So we will see today such kind of things which we can create using AR, VR. So I had planned a different session altogether, but I'll cut down and make it short to go to the core idea of AR, VR. So how many of you have known what is exact difference between AR, VR, XR? That's where I will start with, okay? So please give me a few minutes to make you realize. If you already know, that's great, but if you do not know, there is a thin line between all of them. So let us believe that what this is reality, something which is virtual, I am trying to imitate, and where do we stand? Now, when I talk about AR or VR, right, augmented reality is something which is very near to reality, right, and I am trying to augment. What do you mean by word augment? Is trying to add on something, right? So reality exists, over that I am trying to put something virtual, is something called augmented reality. And where do we move into virtual reality is I am bringing a whole new world which is far away from the real world, and trying to put it into. Now, when I know what is augmented versus virtual reality, I will repeat back. Augmented reality is something very near to reality. Virtual reality is completely away from reality and very near to the virtual world which I have created for myself. Now, where does this XR or extended reality stand? So I see that people are good into immersive technologies and things like that. So do you think AR gives you more immersion or VR gives you more immersion? Quick answers. AR? Okay. So in a realm of AR, VR, probably VR gives you more immersive experience because you are not seeing the real world at all, right? You are immersed into something world altogether by itself. And AR is all about creating new virtual objects which are not real in the real world, okay? And when I talk about XR, it is about interacting with the world, right? I am able to touch them, I am able to turn them, I am able to interact with those objects, right? More of a human robotic kind of interaction, right? Is called AI robots, and now the field called AR VR is coming in where I can interact with virtual objects. I am able to touch those objects, I am able to have haptic gloves where I give the sense to the human, right? So Government of India came up with a project of digital creation of heritage sites where IIT Bombay people created session where people used to feel the stone chariots itself, right? I can have haptic glove and move around a virtual object and I can feel that. So that kind of a technology is coming in. So we would be venturing into virtual reality and augmented reality in coming days. So being equipped is what we require ourselves into. So I hope I have clearly distinguished this thin line between AR, VR and XR. So AR is all about real world and augmenting virtual objects into it. VR is all about virtual world, the whole world is virtual. So games what you play are AR or VR? It's completely VR because it's a virtual world, right? I am only able to see only two of my hands there, which is not real. And after a few minutes, I keep playing that game, I am completely immersed into it. I feel like those hands are mine, right? That's what immersion is all about. So my brain creates that immersion actually. Okay, so I am able to create that immersion inside. So how my human brain is capable of doing this immersion is, it cannot be trained negatively, it can be only trained positively. That's how a virtual game is created. Now, to give an example, I will tell you an instruction which you need to follow. Okay, please do not think about a red elephant. Okay, please do not think about a red elephant. Can you do it? Do not think about a red elephant. Okay, I am telling you, please do not think about a red elephant. Now let us change the color. You are able to think about red elephant, right? But I am asking you not to think about a blue elephant as well. Okay? That's how our human brains are trained. Right? I cannot tell my brain what not to do, rather I can tell my brain only what to do. So it can be trained only with positive samples. That's how humans are more powerful than AI machines, where I need to show it positives and negatives both. Anything which is not positive is a negative sample for me while I am training. So AR, VR is all about creating what is making me feel that I am immersed into. So that's where we are heading towards. So I give you an example, how do I fool my brain, right? It's not easy to fool my brain. It's very intelligent. It is controlling me all together. It is thinking. And what ability this Gen AI which is coming in is giving all this technology is the essence of human being more than machines, right? So it's like, if I train my machine to think by itself. So how many senses do we have? 5. What is the 6th sense that human has? I can visualize things, right? You can visualize me fatter than I am, right? Easily. You can visualize a crown on my head. You can visualize horns on my head as well. Okay, but which machines cannot do. It's really difficult for a machine to do, and we are trying to bring in that reality through this AR, VR technology. Okay, so I hope I'm connecting, and let us move towards the fundamentals. Now, I will not put forward a lot of math here because people might not be interested in listening to math a lot, but these fundamentals are required to understand. Now, when I say AR, VR, what are the basic 3 components that I require, right? So, I talk about viewer that is there, I talk about the object and the light source. Now let us imagine in a scenario where one of them is missing. Okay, let us see, one of them is missing. Have you heard saying that cat drinks milk keeping its eyes closed so that people should not be able to see it? It's like that, right? So that's where I connect. Okay, so are you relating with what I'm saying? So all these 3 components are much required. If I don't have a viewer, I have light and the object, my eyes are closed. Can I say I am creating something virtual or real? I am not creating anything. If I don't have the object itself, I have light source and the camera, I am still not creating anything. So we cannot miss any of these components in my AR VR. So what are we modeling? In a code for AR VR, we are trying to model only 3 things. What are those? Can you repeat with me quickly so that it imbibes into your minds? Purely this is into graphics, right? So 3 things very important. Can we connect to them? One is object, viewer and light source. So if we have these 3 elements programmed, it's all about virtual or augmented reality. Now how different are these 3 elements in virtual versus augmented reality? Can we put together? Can you think and let me know how different are these 3 elements in my AR and VR setup? In my AR, the environment objects are created, the object itself, environment objects are real, only the object with which I want to augment is virtual and object is present. And the light source, in the environment, the light source is real, on the object, the light source is virtual, and the viewer, both my real world and my augmented world is viewed through a single view, that is my camera. Okay? So, in augmented reality, where in my virtual reality, the whole objects present in my virtual reality are virtual, the light source is virtual, the viewer is again a camera, right, but not capturing the real world, it is rendering things. It's a virtual camera by itself. So that's the difference between a AR VR setup. So if I'm able to connect to this, if I'm able to connect, then we will move ahead. Anybody has any queries still here? Because I'm going to build over this. So should I repeat this once again? Yes? Okay, great. So there are three components in any AR VR setup you pick up. You program it, you use it a tool, you pull them, whatever, right? There are only three components. One is object, light source, and viewer, right? So object varies from virtual to augmented. Now let us check only a augmented reality environment. What is augmentation? It is very near to reality. So I am adding a virtual object in the real world. Okay? So I am adding a virtual objects in the real world. So the camera is capturing the real world. The light source is real. Right? The object which I have added is virtual only. So which I have created, that's like a teddy bear which I have created. It's virtual in this room itself. So I am able to see it virtual. Okay? So I am putting that object as augmentation, that means addition to this world. So light source on that object which I am putting in my augmented reality world is artificial. Other than all that what you are seeing in the camera is real. Okay? So viewer is my camera. The object is virtual. The light source on the object is virtual. Light source on the real world is real. The environment is real. That's what is called a augmented reality. When I go with virtual reality, it's completely virtual. I am not seeing the world, so my camera is also virtual. It is somewhere else in the gaming session itself. So camera is virtual, real world no elements, so objects all are virtual. The light source is virtual. So in the virtual reality, everything is virtual. All these three components are virtual. So am I able to connect? So it requires tuning, right? Every singer or a musician has his own time to tune his tablas, right? So I'm just doing that. Okay, so let me move with pace later. So once you connect, the terminologies which I'm using, you will be able to relate it very easily. Now, when I try to make my program, there are parameters, right? Every program what to do is all about parameter passing to the function. So majority of are from CSE background. So any program you write, what do? It's very easy. I pull the functionality, I pass parameters to it. So as a user of a library in AR VR, because I'm not trying to build it from scratch, what am I trying to do? I'm trying to pass parameters, and you need to know what parameters those are. So if I'm creating an object, can you tell me what parameters can it take quickly? Size, geometrical constructs, yes, position, very good, position, then color, probably attributes like texture. If I am making a glass ball versus a football, both the textures are different, but both geometrically are similar, right? So texture, the reflective surface, the radiosity. Now what is the radiosity is, if I'm, okay, can you tell me on my face which light is falling out of this? Which light out of all these lights is falling on my face? All? Really? So can I trace that back? Really difficult, right? So majority of challenges lies in graphics. When I say a graphical world, a gaming world, if I show you a virtually created object versus a real, will you be able to identify them? Yes or no? Yes? How? How will you be able to identify a virtual object and real object? The real object behaves real, that means touch and feel. If I am only viewing it, dynamics of the object. Can you define that dynamics? The attributes, right? So attribute. Now whether I am present here or my model is present, you might have seen wax models, right? Modi ka wax model kiya, right? Some other people's wax model. What is the difference between that wax model and me? Really is the attributes, the way it has been designed with, right? Probably photograph of both, still I know who is real, who is not. However near they might be, right? Graphics are also the same. I have tried to model that attribute, but some subtle things which I cannot model are missing. That's where mathematics fails. That's where AI is coming in. The things which I cannot remember or things which I cannot define as parameters learned by this AI. Okay? Now, to give an example, can I ask you, how do you remember your parents? What are the features of your parents? Can you define them on a paper quickly? If I want to identify your parent who is standing outside. Can you define them quickly on a paper? Attributes. Say 5 feet, this inch, this face is like this. These are the characters. Can you? It's really difficult. Really difficult, right? So I cannot define them, but I am able to identify them. Can you tell me what characters those are? By face, you identify them. If my face is closed, can you not identify them? Still you can. If you say height, if I am sitting, will you not identify me? You will identify me. So I cannot define what are those characteristics which I am defining to identify a person. To give you an example, poems. Probably you might have heard about poems in schools. Learnt? So which did teacher teach you those poems? Or you learnt it on your own? Teachers taught you poems? Or there was given task, right? Tomorrow I will ask you this twinkle twinkle little star, you need to learn and come, right? If you could not recite it, you would get a hit on your hand and then you would recite it next day, right? So there is no pedagogy to teach you poems. They can tell you meanings, but how to remember that poem cannot be taught. It's really challenging, is it not? Similar way, what parameters to model in a graphics is really, really challenging to define. Okay? So whatever programs give you is a limit. So I have put into these attributes, probably only these many attributes are not enough to define. So there is a large diversity that is required to model real world objects. Okay? So what are the challenges in AR VR is what we are going to see. Are you with me, all of you? Yes? Am I connecting? Okay. If not, please let me know. So I was talking about materialistic property also. If it is a rough surface, I will easily know. If it is a reflective surface, smooth surface, I will easily know with the reflective properties. Okay? So these are different transformations that I apply on those objects. Now we started with the materialistic property of the object, but all this graphics is all about transformations. Okay? So what do you mean by transformations? Transform is to put the same model into a different form. Probably if I am here, I move by 1 unit on my left. Today I can model this as mathematically as possible. My geometries are modeled onto a different coordinate system by multiplying these matrices. Probably I am doing it at 6 DOF, right, degrees of freedom. Now human has around 206 degrees of freedom. Okay? What do you mean by degrees of freedom is, now if I say my hand, it cannot go down, right? I am limiting it to only this. The degree of freedom left with me. More of robotic people can understand this very easily, right? But I can rotate this. So the degrees of freedom defined are very different than as compared to a robotic arm. So I can define a robotic arm with larger degrees of freedom, but it's really challenging to define. When I say that I can put into any object, what am I trying to do is x and y considered, my new x and y, I am multiplying this with one matrix. For reflection, translation, scaling, we have different matrices that I multiply. And finally trying to put an equation into a matrix form so that I can multiply, transform the object into new coordinate system. Okay? So if I am standing here, I want to move one step, I will use my only translation kind of a matrix that puts this transformed object into my graphics. Okay? So old xy coordinate of mine being put into new xy coordinate with these transformations. Okay? So I will not dive deep into this, but let us understand what these are. Okay? So basically when I want to keep the object as it is, I will consider this identity matrix. If I want a reflection of the object, I will take only minus of y so that I have a reflection. That's how your mirror is all about. When you take a selfie, it's really reverse, right? So when you take a selfie and save it, probably who was on your left will come on your right, because that's what is a reflection image which is saved. Okay? Translation is moving, scaling is becoming larger or smaller, right? So we have rotations. Again, the object can be transformed in all three directions. Shear effect is like keeping a butter and then pushing it, right? So it tilts, turns, but shape remains. Okay? So square will become a rhombus. So you can see all these shear effects here. Why am I putting all this is because on an object, what you can do is only transformations. On an object, you can do is only transformations, nothing more. So any geometric object you pick up, you can only do these transformations, nothing more than this. It's a permutation combination of all this. Okay? Getting this? Connecting? So probably I have taken 15 minutes to introduce you to what is required. Now, if I talk about degrees of freedom, right, there are only few degrees of freedom which I look at. Say 3 dimensions, world, how many degrees of freedom? How many? 3 degrees of freedom plus 3. Can you see up? Up has down as well, right has left as well, right? Back has front as well. That's what is dimension, 3 dimensions. Then roll is among this, aeroplane rolling, yaw, right, and pitch, changing, right? So, simple looking 3-dimensional degree of freedom also if I give you, you will have a complex viewing or transformations that is required, okay? So, if I put a camera, then camera can take all these dimensions to move. So, what parameters do I pass to my functionalities? Whether I have a roll, whether I need to move left or right, whether I have to go front or back, whether my pitch is changing, my yaw is changing, and so on. Only these parameters are passed to your algorithm. Is that clear? I hope I am connecting. Okay. So, when we have these degrees of freedoms introduced, right, my views also change. Okay. Now, when I am standing here, I see the back benches being smaller, the front benches being larger is because of my perspective view. So, when I am putting all views into my reality, how do I make something look like real is all about putting these views proper. Okay. So, if I have a laptop in front of me and I am viewing it, if I move side, the laptop will not turn towards me. The view is always orthographic, right? So, probably in engineering design, people might have seen 3 views, front view, top view, side view, enough for constructing a 3D model, right? All 3 views given, I can reconstruct a simple 3D model very easily. But those orthographic views will not make them realistic in this world. So, when I am putting that in the real world, I need to know whether it is a 1-point perspective, 2-point perspective, and so on, right? So, isometric, all these views are very required. I am not deep diving into this because you need to know what these are, because when you are working on Unity, you are changing these views as well. So, what did we see is object, viewer, and light source. There are 3 elements, key elements. First one is object. On object, what can I do? I can do transformations. Second is my view or a camera. What can I do there? I can change my views, multiple views I can do, okay? And then there are 2 types of views. One is orthographic, where all the projectors are parallel to each other and my viewing frustum is like this, okay? I have 3 views. Similarly, I will have a oblique view, right? That's called axonometric view, where I have diametric, trimetric, and isometric, where all the 3 angles are same. If theta 1, theta 2, theta 3, all 3 are same, that's different, again one view. Oblique view, that means my projector is parallel, but my object has moved. And this is very important. When I want to make something real, okay, when I want to make something realistic, I need to put it into a perspective view, okay. So, perspectives are of 3 types. One is single point, right, then I come 2-point perspective, there comes 3-point perspective. How do I model this? 1, 2-point and 3-point makes it look very real, okay. Orthographic views generally are not realistic, okay. Any form that comes in front of you, a touch screen kind of thing, right, in a AR VR element also is orthographic in nature, not perspective in nature, and all other elements I am trying to put it virtual. So, what all did we cover is this camera viewing frustum. So, when I am putting a camera into this coordinate system, Cartesian coordinates, right. So, I have my camera viewing at one, see it is like my face facing here, but my eyes can move like this, right, I can move. So, my face looking at and my position matters. So, there are 3 vectors that I need to pass. So, why am I putting all this is because when I am coding and implementing, that is what I was told, and in detail how to do this in Unity is covered by Sindhu ma'am tomorrow, probably who is coming as a resource person, but I am setting the fundamentals that are required for the course. So, these are the 3 vectors you need to plan, and that is what you give as an input to your Unity platform, right. I am modeling, looking at, I am looking where is the eye and so on, okay. I am sharing these slides with you so that you have a reference material and also refer back. So, it is on the Atal portal, you can refer them back. Then comes the third element. We saw about object, we saw about the viewing. The third comes light source, which is very important to model. So I have different light properties that I need to model when I want to make it realistic. Now, if I model a augmented object, suppose there is a virtual object kept in front here, okay, and where do you find that light source for that model? Should I model the light source exactly the same as that of what is in the room, or can I put a special focus light on it? If I put a special focus light, you will know that that particular object is virtual. But if I want to make it look realistic, what I need to do is model all those lights which I put in the virtual environment at the same position with the same color. Then only it will behave the same as what I am behaving right now. Okay? It should not look like a decorative Ganpati which you have kept somewhere and putting a focus light on it. Okay? So what happens if I do that is I am trying to put some virtual light onto object which easily can be identified as an augmented object. And what is my agenda? My agenda is to make it look like real in any scenario, right? So either it's augmented reality or virtual reality. I want it to obey what this real world actually does. Okay, it should be very similar to the real world. That's what is my agenda. So there are different types of lightings, right? Smooth surfaces, rough surfaces behave differently for a simple light, but I have different lights like point light, which is put into all directions, like sun, right? It is putting light from all directions. Spotlight, which is putting on the object very specifically. Ambient light is, I don't know the source, where is it coming from, right? Ambient light is a light which is defined without the knowledge of the user where it is coming from. It's really far, okay? Can I say sunlight falling on me, I move and the light changes? It's really difficult to say. So such kind of light is called ambient light, where I don't know the source and I'm not directly seeing the source of light. Then comes directional light. I just know the direction it is coming from a window, right? These are all directional lights where I know just the direction coming from and it behaves similar every time, okay? So I model this. Why am I putting all this is because you need to select these parameters in your Unity so that you can model these things, okay? Now, I have put the fundamentals of AR, VR which are required. Now we are venturing into AR, VR. My slides have kept it really dry. Why? Because you need to know the essence of AR, VR when you come here, right? So I will show you my slides very dry so that you appreciate the essence of AR, VR in the next coming sessions, okay? Till here, for the fundamentals, any questions? Any questions for fundamentals? Yes. Yes. Now when I say that I am trying to put a virtual world into this, right, virtual object onto my reality in augmented reality, without understanding the world around me, right, the perspective of vision, what you are saying, without putting that, if I can model an object, right, what will it miss? It will miss either the properties of the light, either the properties of the object, or it will miss view. Which one do you think it is missing? If I am trying to put without that vision perspective what we are talking about. To understand this, we will ask you a simple question. I hope you people have heard about image processing, right? What is image processing? What is the input to image processing? An image. What is the output? What is the output of image processing? Processed image, right? That's why image processing is all about. I give the image, output is an image. What is graphics? Graphics is parameters given, output is what? An image, right? I am creating a 2D, right? Finally, end of the day, either it might be 3D, 3 dimensions cannot be viewed. So you are putting it to a 2D screen only. So any graphics you do, you are viewing it in a 2D screen only, correct? So for graphics, the input is parameters, like I have an object of this XYZ coordinate and this color, I render that object, right? Graphics. But when it comes to vision, what is computer vision? Computer vision is given an image, understanding its parameters of the real world. Can I estimate those parameters of the real world, okay, dimensions of that particular object, geometric, properties, whatever, where is the object, the bounding box, whatever, right? So position, the angle which it's making with me, all these parameters are estimated by seeing that only 2D vision. Okay, so I have a two-dimensional image and I am trying to understand about the world where it is and its properties. That's where vision comes into. And that's what enables this AR/VR. AR/VR is enabled because of vision. Because a human perception can be brought from an image, I am able to analyze the world and then put a real virtual object into it. Okay, until unless I understand what is the environment, suppose I want to put a teddy bear, that's what I said, teddy bear here, I first need to understand or analyze the environment. Then only I can put it. Where is it put is the position. How is it being put is its geometry. The light source which is falling on it is modeled. So everything without understanding a vision perspective, I cannot put it. So vision perspective is must to enable AR/VR, both, right? And where are these vision perspectives coming from? The viewer perspective. Any questions still here? I am waiting for questions. Yes, sir. Yes. Course on AR/VR. We are already started. It's a elective. Yeah, it's like now, it's like an enabler which is required from the university is from the perspective of admissions, right? Now, any university you go with, if I start a course on AR/VR, all the jobs they do is in AR/VR, right? We are facing the same challenge in AI right now. The industries are not coming out with AI kind of a course because they want computer science engineers who can do software engineering as well as AI. Yes, yes, yes. Computer science and a graphics mode. Whole vertical is graphics. Yes. Yes. Bothering is admission, sir. When I say parents, right, they do not have these FDPs to train them on what's AR/VR and what's the potential. Definitely, but they don't understand it. They finally see placements, right? And majorly companies working in AR/VR do not come to tier 2 cities to hire people on AR/VR because if I see vision community, hardly vision community is there in IIT Madras and a few places in IIT Hyderabad, IIIT Hyderabad and in Delhi. So they go to those places and hire and the limit engineers can do this stuff again. So building a whole course by itself of strength of 60, 70 people, hiring would be a major challenge. And that's what we foster and see. Any questions? Okay. So let us start with understanding what is virtual reality. Now, this diagram actually speaks about what virtual reality is. Right? I am trying to put into a globe, this globe, and he is able to see only the globe and he is trying to interact. Right? But really that interaction is not possible in VR. You need to have keys, you need to have other interactive event tools or logistic tools to do this, right? So without this AR/VR tools, it's really challenging to put a person into immersion. Now we will see what are the key components that are required to design this AR/VR models, okay? So these are a few applications which I wanted to show you. This is designed by one of the startups coming from KLE Tech itself. This is a virtual lab which they have created. It's a VR setup where students can do their experiments, right? Note down all these readings. And this was a company called Labinap which was took over by Byju's, but Byju's closed again. So they are again independent now. They are coming up with new platforms where they can launch, and it was a good business startup which they did. So all these experiments probably in second year PUCs people might have done. A lot of people sitting here might have done these experiments, right? Similarly, I heard that there was a farmer who did this experiment by putting this VR gear onto cows and gave them hay, right? Their milk productivity went by 10 times, okay? So they were making them eat hay, which is dry grass, but giving them the green grass kind of a picture which they were eating, the milk productivity doubled, tripled, and now it's 10 folds higher. Similarly, flight simulator, this is from DRDO. Yeah. Yes, simulations are, you are trying to imitate the real world into some fundamental thing, right? But when you say simulation, you are bound or it's finite to real world. Simulations are not fictitious. You might have watched Harry Potter movie, right? Harry Potter is fiction movie. Why? Because it's way beyond from real world, right? I can make magic there, I can do wonders. I can jump from this simulator and not die, right? But generally, when I say simulator, it's real, very near to real world. What I can do in real world is possible in simulators, but what I cannot do in real world is possibly done in my VR. So it's like Jupiter, I can turn by my hand, which is not possible in reality, right? That's called virtual reality. So this is coming, Samsung has launched a new platform, probably in Bangalore. If you are there, you go to this MG Road, there is a Samsung studio, right? What's it called? Opera House. You can go and visualize this. These kind of things are there, where you row boats, when you run on treadmill. You feel like you're really working on a treadmill itself. You're really going into the real world. Okay, so please go to Samsung Opera House and visualize this. It's free. I think you can go and check all these platforms which are there. Now, when I say I'm designing an application in AR VR, this is where the actual dry AR VR starts. Okay, when I talk about concepts of AR VR, there is nothing more than math. There is nothing more than graphics that I can show you as output, but need to understand these terminologies. So I will put forward a few elements that you need to know about AR VR. When I say that I want to design application, what you need to keep in mind is the first perspective is immersion. So how do you enable immersion? Can anybody give me insights on immersion? What do you actually mean by immersion? Fooling the mind. Can I limit that to only fooling the mind? Immersion can be enabled by what? Really is happening. So I am fooling my senses, I am fooling my brain that this is really happening, which is not happening, right? So I am forgetting the world in which I am. So some of my senses are enabling the world, some of my senses are enabling this virtual reality, and if the amalgamation of both these happen, I say I am immersed. Okay, that's what happens when you go to a temple, right? Your mind says I want to go spiritual, but the physical world around you, people pushing you, reality is happening, but you are connected with the God, right? I am folding my hands and in front of Him, I am asking Him, I am just connected. That's what is immersion, right? My senses all around pushing, there is bells going on, there are prayers going on, there are people around me. But real challenge lies in what do I feel like being immersed into? Okay, I feel connected about some point. That's where it is important. Then comes my presence in that particular environment. I need to be present in that environment. I need to make myself available there. I need to have those objects with me, right? I need to see to it that my field of view is the same as that of real world. Okay, my field of view now is, what do you see? Can you see? Can I see my hands now? Do you feel so? I can, right? At this point. Beyond this point, I will not be able to. So can I model this field of view in my camera? Really challenging, really challenging, right? So whatever AR, VR gears we have around say 140 degrees, right? But my human brain can see, right, more than 170 degrees. So fall short of that 30 degrees also makes it virtual as compared to towards non-immersive nature of the cameras, right? So non-immersiveness might be because of deviation from the reality as well. So my brain is capable of seeing till 170, 180 degrees, but if I am showing up to 140 degrees, then there is a real challenge. My brain is not getting fooled. Okay, let us do an experiment. Everybody has a pen in hand? Pen with open? With open or not? Is it with open? Right? Cap is there? Okay. Open that. Let us open eyes, both eyes, and put that open quickly. Keep your hands like this. Hands like this. Fast. Put it open. Easier? Yes, very easy. Okay, keep your hands free, don't keep it on any table, keep your hands free. Now open, close one eye, make it far, take it far, put it. Is it that easy as that was with two eyes? Why? Why? Because my two eyes were giving me the depth sense. Now one eye is not giving me that depth sense, but still you are able to do it because your brain has learnt a lot of things. Right? Brain has learnt a lot of things. With one single eye, you know this is far, this is near, this is far. But that a kid cannot do. You ask this to a 5-year-old kid, he will find challenges to do this. Why? Because his brain is not tuned for doing all this. Okay? So when you see a small kid, right, he is learning, you see them grabbing, he does not know how far should I stretch my hand to pick something. It's because of that learning happening. The cognition, that presence, that immersion is not there with him. A baby, when it is born, it cannot see beyond 10-15 centimeters. And then I go larger, now I can see the whole world. Okay? Then comes stereoscopy, that's what I showed you. Stereoscopic is two eyes, and I am doing that experiment where I require two eyes to look at the world in the immersion phase. Then comes interaction, which I am able to do, right? So we'll move on what actually these are. So first one is immersion. Immersion actually talks about the extent with which user feels that the whole world which around him is complete. Okay? That immersion is what I need to bring in. So can you see that person really trying to touch things? He's not bothered around what is happening around him. Okay? You should see people who are wearing those gears and standing. They are really immersed, they don't bother how they feel, what's people seeing me, how are they seeing me and all. Right? They are not bothered. That's what is all about immersion. Next comes my presence, that's about being there in the world and sensing my real behavior. Okay? So can I make person behave the same as that of what he is behaving in the real world? So as I talked about my human vision, right? In blur I can see up to 220 degrees, but all these are different gears which are capable of giving only 90 degree here, 110, 135, up to 170 degrees is what is the maximum. Okay, beyond this, whatever this dimension is there, that is lost and I am away from my vision, and that's where these challenges are being faced. Then comes my tracking, whether I am able to track where I am. Tali Chakraban Bidiri, what happens is my mind loses that track. Okay, try to walk with one ear closed. Okay, you will lose the track. One ear closed and try walking, you will go like this. Have you seen towards the train and started walking? In a railway station, go, stand in front of a train is moving, right? Move opposite to it, seeing towards the train. Can you walk on a straight line? You will not be able to walk. Why? Because you don't have a track. Your mind loses track when it is a moving object. Okay? So when I am running, I lose my control is because I lose track of the real world, what is happening around. Okay? So such kind of things are enabled. This is what is stereoscopic vision. Can you see two images overlapping? Right? I have kept it overlapping. That gives you a sense that it is in 3D, but it's only two 2D images being toggled. That's what is stereoscopic vision. This is how human is able to perceive depth. Okay? Two views seen together makes me feel that the world is three-dimensional. Then comes different interactions that I am able to do in the world, probably with the joysticks or something, or haptic gloves. I am able to interact. These abilities given into the AR, VR stuff, what makes it more immersive. Locomotion is kind of having a track plus awareness about where am I moving, how am I moving, in which direction. It's about start point and end point, which I know. This locomotion is very much important for robots. Right? They are aware that they are in a local environment and moving, but until unless they have end and start point, I will not know where to go, where to head. All my abilities are of no use. The major challenge in AR VR devices that people design is the motion sickness, right? because it is deviating from the real world. If you wear these AR/VR devices for more than 15 minutes, your brain gets started tuning to those things either, or it gets fatigued because it is believing that something unusual is happening. Have you ever woken up seeing a dream? Yes? Can you go back and start again? I was seeing something, oh, 2 minutes, I will come back. You cannot. Because you have lost that locomotion track, one, where it is coming from, where it is heading to, I don't know. And because of this sickness, right, my brain erases it all. It understands that, oh, I was in a virtual world and I now am in the real world. I cannot go back. That track is lost. That pointer is lost. Okay, I cannot go back. Then enabling one more sense. Visually, I am enabling things, but large amount of vision. Okay, let us do this experiment. Can everybody close one ear and tell where I am? Close your eyes, close one ear, and now tell where I am. It's really difficult to tell where I am, right? So visualize where I am. Okay, so I am walking, one ear closed, and visualize where I am is really difficult. Now open and check whether I am in the same position where you are visualizing. It's really challenging, but keeping your 2 ears open, it's really easy. Why? Because this spatial audio is very important. Okay, whenever I am going to enable yourself into this virtual reality realm, you need to know spatial audio plays a very vital role, because whole senses, the balance of human is controlled by ears. Okay, human is controlled, those waves. I am listening to or hearing to a few objects around, right? But real challenge is my ears are made to balance. Okay, ears are made for human to balance. The waves are being captured. You are able to hear a few frequencies, but beyond that, some frequencies are there which you will not be able to hear. Go and sit in a calm and quiet place. Okay, do not hear anything. Challenge given. Okay, or sit quiet and don't think anything. It's the same. Okay, everything what you hear a sound, right? That's what is the wavelengths that are being captured by ears, and it is creating that essence of being immersed. Okay. User interface, we will not talk about this because again CSE people largely know what this is. Then comes platform, where I am optimizing all this happening. Now if I give you a AR/VR gear and it has a lag, I turn from here to here, right? I turn and then it takes some time to come. What happens? What happens? Whole immersion is gone. And to enable that, what I need to do? Optimize my level of details that I want to go in. Okay? Then I need to test, iterate, check whether all those elements which are there in my immersivity platform enabled, all these are enabled through iteration. It will not come in a day. It will not happen in one go. You have modeled a lot of things, but they all have limitations. At some point, they will fail. When you want to create this immersive experience, right, you need to give some behavioral patterns, right? I need to give realism and I need to make the user believe that he is into that platform. Otherwise, it's really challenging. And can you tell me what was the challenge with you understanding what I am now showing versus I showed you a few first slides, right, where I was putting what is AR, VR, right? Did you connect there well or here you are connecting well? There, a few people connect here well, few people connect there well. There is no general thing where I can say, okay, you only connect here well. Here, what am I doing? I am giving a list. I am making things finite. There, it was about imagination. You can imagine beyond. Okay? Visuals. The difference is, here you are allowed to visualize. There, I am making it finite. Is it not? I was not allowing you to visualize anything beyond Earth as a virtual environment. But when I say here realism, you can imagine whoever you want. It's not ending. It's going anywhere you want. Are you there? Yes or no? Okay. I will not spend a large time on this because these points are shared. We will go to similar things for augmented reality, right? So what I want to do is, when I say creative and VR experience, when I want to create experience, these are the things which you need to keep in mind, right? I will just read through. when I say user comfort and safety, right, it's about creating a bound of virtual reality. If I wear a gear and I'm walking in a room, right, I might go and collide somewhere. So all these tools, what they do is, they allow you to keep a boundary. When you are going out of that boundary, they stop you. Okay? So whenever I say I am designing a VR experience, I need to keep into track all these points, right? Reduce latency, his safety, and all those features in. Okay? So I will show you all this coming back to modules of my AR VR application. When I say modules of AR VR application, what do I require? So I will require my modules to have user interface, rendering module. What do you mean by rendering module? What do you mean by rendering? So is there a 3D rendering possible? Using what? See, any screen, if I show you a 3D model here, is it being rendered on a 2D or 3D? Today's gadgets can only render 2D, right? They can create an illusion of 3D. Let me ask you this question. When you are viewing something in a 3D movie in a theater, can you peep back and see who is there behind that dancer? Why? Because it's 3D, you should be able to. But it's actually 2.5D. Okay? You might have heard about 2.5D. Any depth camera gives you 2.5D. What it means is, I'm capturing 2D versus the depth here. If I peep back, I will not be able to see anything. Right? It's 2.5D. It's not complete 3D, it's 2.5D. That's where the limitations of 3D are. Okay? Any virtual world I create, any sensing device I have is limited. It is not complete 3D. However good sensor it might be, it cannot capture 3D right now. No sensors are there which can capture complete 3D. Okay? So when I say that limitation of gadget itself is to capture only 2.5D, how can I enable something visualizing more dimension than what it can capture? Maximum it can show you is 2.5D. It cannot go to 3D. Okay, why am I rushing is, I have 10 minutes more and I need to give you a sense of the AR as well, right? So these are different components of a VR system, right? So head mounted display, right? Tracking system, input devices, these all, I will share this, I hope you will be able to see. But when I want to develop a VR system, this is what is important and what we will see in the afternoon session, right? So I have a desktop VR system where I can interact with a VR system like this through a desktop where I am trying to establish things and I am able to interact. Then comes console where I have a PlayStation kind. Many of your kids might have PlayStations with them. That's also a VR platform. And you know how kids get immersed into what technologies they have been into. Okay, mobile phones, probably a lot of people already are immersed into mobile phones. So immersive technology like this. Then comes standalone where you can see what he is seeing in this. Okay, this is his vision. What he is seeing here is being projected. So he is playing a sword and able to cut that, but he is not bothered what other people are thinking about what he is doing. Then comes a room scaled version. Can you see that that person is playing here, but that is particularly room scaled. What do you mean room scaled is? A room being kept like this hall and inside this itself is made to play. The walls, whatever are virtual also are in reality. Okay, this is becoming a boom today, right? You can see that he is in real, but he is seeing the virtual things in his mind. Then comes augmented reality and mixed reality applications and cave. This is very fascinating where only projections on the screens are made, right? It's called a cave, right? Virtual environments that are created to visualize. A lot of architects are using this kind of stuff today. Then comes haptic devices. Can you see that there is an interaction being happening here with the object? Same interactions in this virtual world versus reality. Without the object, same interactions I can map. Can you see here also? So these are used for robotic operations and things like that. Then web portals, web-based applications where I can see, visualize for students. Okay? So into VR. we'll see this in the next session, probably. Okay, so we understood what actually VR is. We have a glimpse of what actually VR is?